Okay, we're ready to start section 5.2. And what we're going to be looking at in this particular section is the law of cosines formulas. So, first of all, first thing I want to show you is law of cosines. It has actually several different formulas. So the law of cosines takes on these three forms, so it's the same formula for different cases. So first of all, what I want to do is attempt to kind of show you this to begin with. Let's start by just drawing some sort of a oblique triangle. The law of cosines works for all triangles, but I'm going to start off just by having you draw some sort of an oblique triangle of your choice. And I want to show you basically how this works and a kind of a way that'll help you remember the law of cosines. Because it's actually, if you remember and memorize the law of cosines, it speeds you up a little bit when you're solving problems. So let's start by doing some labels, some sides here. Let's say that this is angle alpha, beta, and gamma. And of course, that would force the sides to be side A, side B, and then side C like that. So if you look at a law of cosines formula, here's how it basically goes. If you pick a side, so I'm going to pick like A, side A, then it ends up being that what you do is you take the sum of the squares of the other two sides. So you do the sum of the squares, then you do twice the product of those two sides, and then you do the angle in between. So these are the four variables that are going to exist in all of the law of cosines formulas. So when I look at this, I try to get students to kind of say this in words. So it goes like this, okay? Pick a side. Let's pick A. We say the square, A squared is equal to the sum of the squares of the other two sides, okay? Minus twice the product of those other two sides, times the cosine of the angle in between those sides. Or you can think of it as that angle alpha is opposite that side, like that. Okay, now I'm going to erase that and I'm going to do this a different way. Just going to kind of start over again, and I'm going to show you how the other formulas work. They're all the same anyway. So let's again just call this alpha, beta, gamma, A, B, C. Okay, so let's pick this side now. So let's pick this. When you develop and remember how this formula goes, you pick a side and you square that. That's going to be equal to the sum of the squares of the other two sides minus twice the product of those other two sides times the cosine of the angle that is opposite that side B. So it would go like that. All right, so that's kind of how that goes. You want to kind of practice that and make sure that you can do that okay. Here's the other one. If you said, pick another side, so like if you pick C squared, that's going to be equal to the sum of the squares of the other two sides, A squared plus B squared, minus twice the product of those other two sides, AB, times the cosine of the angle opposite like that. So it's actually a very easy thing to remember. Okay, the law of cosines works with two different formats. So I'm going to draw a triangle here and show you. Here's one example. If you're given all three sides of a triangle, so say like this is 10, this is 11, and say that's 12. Okay, you can use the law of cosines when you're given all sides, and the reason is because if you look at the law of cosines formulas, they always have all three sides in it, and then you would have a leftover angle that you could solve. Okay, so for instance, if you knew all the sides and you wanted to find what gamma was, well, you could just plug in for those sides, and then you would have everything figured out from there. So you would want to use the law of cosines whenever you have a side case. The other case that you can use this for is the side angle side case. So this would be, as an example, say that you know this side is 10 centimeters and you know this angle is, say you know that this is 110 degrees and then this side's also 10 centimeters. Well, you could find this side, and let's just say that's gamma and C. So if you're given a side, then an angle, then a side, then you would do the law of cosines basically like this. You would just take the side opposite the angle, c squared. That would be equal to the sum of the squares of the other two sides minus twice the product of those two sides times the cosine of the angle opposite that c, or in between those two sides. So you would end up having this set up, and then you would be ready to get your calculator out and find that then. Okay, so what you want to do is when you see side, 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 you can use law of cosines. And if you see side, angle, side, you can use law of cosines. Okay, so let's solve a few problems. So I'm going to start this problem number 2 down here. Again, just by drawing a picture of a triangle to kind of help us visualize what's going on in the problem. So go ahead and draw yourself out a oblique triangle of your liking. And it doesn't have to be drawn to scale. You just got to get everything labeled correctly so you'll have a good visualization of what's going on in the problem. So what I'm going to do is I'm going to call this gamma, and gamma was given as 126.8 degrees. I'm going to go ahead and call this alpha and that beta. Now notice I was given side A is 6.40, and then side B I was given 11.46. So if you look at this, what I've been given is side, angle, side. So the law of cosines, it would be the ideal way to solve the problem. So I'm going to start with side C. Now without doing this, so you want to be able to build the law of cosines yourself. You need to find C. If you've got the side, angle, side case, then start with that missing side. So the law of cosines goes like this. If you take that side, that's going to be equal to the sum of the squares of the other two sides minus twice the product of those sides times the cosine of the angle that's between those two sides that you're given. So that's how that would go. Okay. Now what I meant to put on this, I think, was a gamma. So then we'd be ready to set this up. Okay. Now I try to get students to get it memorized, because then what you can do is just plug in the formula without even having to look at the formula. So what you do is just square sum of the squares of the other two sides. So those are 11.46 squared plus 6.40 squared minus twice the product of those two sides, 11.646 times 6.40, and then you do the cosine of the angle between those two sides, or think of it as being opposite the side you want to find. Okay, so you got everything set up. Now we can pretty much just do this in one major step on the calculator. So I'm going to put the calculator over here and show you how I'm going to put that in. You want to make sure, of course, you're in degree mode when you do this. So I'm going to type it in exactly as it is. We're going to do 11.46 to the second plus 6.40 to the second minus twice the product of those two sides. So I'm going to put a parenthesis to represent multiplication. 11.46 times 6.40, and then times the cosine of the angle in between, 126.8. Okay, so I make sure I got everything put in. I got sum of the squares of the two sides, twice the product of the two sides, times the cosine of the angle in between. Okay, so I press enter. I'll let the calculator calculate that out for me. So I've got c squared is equal to 260.1611736. Now I'm going to take the square root of both sides. So I'll get my calculator out and I will do that calculation and round that off to 2 decimals. Now what I can do on this, since I've got this already calculated, that's stored in this A and S key. So I can go ahead and go square root. Instead of retyping that, I can go second symbol there, second of the negative symbol, and then it'll do the square root for me. So see what that did is it allowed me to not have to worry about retyping that number in, so it just saves a little bit of time. So I use that A and S key all the time, and you should too. So we're going to round that to 16.13, and then we'll have that recorded as one of the pieces we wanted to find in the problem. So I'm going to go to my triangle and write this in as 16.13, then we'll move on. Now, you could use the law of cosines, again, if you wanted to, but the thing I want you to pay attention to is that anytime you're given an angle on an opposite side and something else, then law of sines can be used. So what I'm going to do is I'm going to go ahead and use law of sines to find alpha. Because, see, I've got 4 numbers that would make up a law of sines proportion. I've got an angle on a side opposite, an unknown angle, but I know it's side opposite. So we're going to go ahead and go with law of sines. So I'm going to put my unknown alpha in the upper left-hand corner. So I'm going to say sine alpha over the length of its opposite side is equal to the other angle I know, the sine of 126.8 degrees, over the length of the side opposite. Okay, then I can solve this. So I'm going to multiply both sides by 6.40. Okay, when I do that, that will cancel that out, and that is going to leave me with sine of alpha equals 6.40 times the sine of 126.8 degrees, all over 16.13. And so I'm going to do that pretty much in one step on the calculator. So I'll go to my calculator and put that in. So I've got 6.40 times the sine of 126.8, close parentheses, divide by 16.13. And then we can record that. So that's going to be 0.31771111453. And see, what I'm going to have to do is I'm going to have to do now the inverse sine of that number. So to save a little bit of time, instead of having to write all this stuff out over and over again, what I can do is I can just go inverse sine and then put A and S, since that's already stored in that memory key, then that'll give the answer. So alpha is going to be approximately 18, let's just round to 2 decimals, or yeah, let's round to 1 decimal, the angle. So let's just say 18.5 degrees. Okay, so we now have that figured out, and then one more thing, and then we're done. All right. So I'm going to go ahead and record that, as we found alpha to be 18.5 degrees. Now I can find my third angle. We know all 3 of these angles are going to add up to 180. So what I can do is just do this to find angle beta. Beta is going to be equal to 180 minus the sum of the other 2 angles that I now know. And then I can put that in my calculator and get that answer. So I'm going to go ahead and do that. So I have 180 minus parentheses 18.5 that I just found, plus 126.8. Go like that. And that'll give the final angle on this is 34.7 degrees. Okay, so I found all the parts. I found my angle. I found that side. Then I found that angle like that. So I'm going to put everything in, and I'm going to remind you one more time that you can tell you're right on this problem by applying law of sines. So I'm going to put my calculator over here, and then watch what I do. So I'm going to start with, you can start with any side or any angle you want to. So I'm just going to start with 6.4, and I'm going to divide that by the sine of its opposite angle, and I'm going to get an answer. Okay, then I'm going to go to side B, which is 11.46. I'm going to divide that by the sine of its angle. And look at that, I get the same thing, almost the same thing. And then I go to C, 16.13. Divide by the sine of the opposite angle, 126.8. And you should notice that all of these results are pretty close to each other, and they're off only because of rounding. So then we've got the problem basically solved. Okay, so it's a good idea to kind of finish up by checking your answer to these problems as you go through these. All right, so that will be the solution of that. Notice I did law of cosines only one time, and then I did the law of sines to find the next part like that. And that's typically what you want to do, is do the law of cosines for your first step, and then law of sines next. Okay, let's move on to a side case. So I'm going to move to this example 3 next here. And example 3, we're given 3 sides. So again, just to kind of help us see what's going on, let's draw some sort of a triangle. Label the sides, and then that'll kind of help us make, hopefully, some sort of sense out of the problem then. And I might not have this thing drawn to scale, but it isn't going to make that much difference anyway. So let's go ahead and get this written on here. Get everything labeled, and then we can see what case we have on this. So let's see. I'm going to go ahead and call this shortest side. The shortest side's A, so I'm going to call this A, 6.6. This looks like to be the longest side, so I'm going to call that C equals 16.3. Then I'm going to call this B equals 13.7. So that means that opposite A is alpha, which we got to find. Opposite B is beta, and opposite C is gamma. So we're going to find those sides, or those 3 angles. All right, so what you want to do on this, the law of cosines, there's 3 different versions of the law of cosines, so it doesn't matter which one you pick. If I want to find side alpha, or I'm sorry, not side alpha, angle alpha, the way I'd want to do this in the law of cosines is I'd go like this, and again, get it memorized. So what you do is you square the opposite side. So you say A squared is equal to the sum of the other 2 sides, B squared plus C squared, minus twice the product of those 2 sides, and then the cosine of the angle that's in between B and C, or alpha. I like to think of alpha, the angle alpha is opposite that side A. So what I'm going to do is this is going to allow me, see, I know A, B, and C in this problem. I don't know alpha, so I have a formula that would allow me to find alpha. Now what I like to do is solve this equation for cosine alpha, and I just rearrange things in my head. You should do the same. You're going to subtract B squared from both sides, and you're going to subtract C squared from both sides. So that's going to leave you with A squared minus B squared minus C squared is equal to negative 2BC times the cosine of alpha. Then I can divide both sides by negative 2BC, and then that would leave me with the cosine alpha isolated, and then I'd be ready to plug in. So what I'm going to do is A squared minus B squared minus C squared all over negative 2 times B times C. Okay, so let's plug in what we have. First thing we have is we got A squared. So I'm going to plug in A is 6.6. And I got to plug in B. B is 13.7. Then I'm going to plug in C. C is 16.3. And then the bottom I'm doing negative 2BC, so B is 13.7. And C is 16.3. Let me zoom on that just a little bit. I can see that a little bit better. Okay, so what I'm going to do is just bring down the cosine alpha. And I'm going to crunch this whole thing out on my calculator. So watch carefully how I do this. The way I can do this in one step, if I want to do this in one step, I could go like this. I could go, have the parentheses, have parentheses around this entire numerator and have parentheses around that entire denominator. And you can put it in like this. So you would just go like this. You could go parentheses 6.6 to the second power minus 13.7 to the second power minus 16.3 to the second power, and then close the parentheses. Now divide by, then you must have a new set of parentheses here. I see students make that mistake a lot. Then it's going to be negative 2 times 13.7 times 16.3. And see, now what this calculator is going to do is it's going to do the numerator, then it's going to do the denominator and divide the 2. Okay, so we'll just write down what we have left over. So that is calculating as 0.917603317. And then alpha is going to be found by doing the inverse cosine of that value. Okay, so to keep from having to continually rewrite stuff, on my calculator I can go second cosine. That is stored in the answer key. So I do that, so that means alpha is going to be approximately 23.4 degrees. Okay, so I've got alpha has now been calculated as 23.4 degrees. Okay, so that's how I would use law of cosines in this case, is I would pull out a formula. If you want to find alpha, use this formula. If you want to use beta, use the formula that has cosine beta in it, and so forth. So step 2 is going to be, we're going to use the law of sines. So all you got to know whenever you're doing the law of sines is you have to know, at a minimum, a side and an opposite angle. We now know that. So let's find beta, because we know it's opposite sides. So I'm going to match these 4 things into a law of sines proportion. So I'm going to start with finding beta. So I'm going to say sine beta over the length of the side opposite, 13.7, is equal to this angle that we know. So we're going to do sine of 23.4 degrees over 6.6. Then I'm going to solve this. Okay, now you can rearrange this in your head if you want to. I'm going to multiply both sides by 13.7 so that will isolate the sine. So I'm now going to have sine of beta. So I'm going to write down what I have. I have sine of beta equals 13.7 times sine of 23.4 degrees all over 6.6. All right, and I'm going to take my calculator out, I'll move it to the side, and I'm going to calculate this. So I'm going to work this out in one step. So I'm going to go 13.7 times the sine of 23.4. And then I'm going to divide that by 6.6 and record that. So that's going to give sine beta equals 0.82438, 27427. And then beta is going to be the inverse sine of that number. Then I can go to the calculator and do that. So what I'm going to do is just go inverse sine, use the answer key because the last calculation is stored. So that's going to be beta is approximately equal to 55.5 degrees. Okay, so now I've got the second thing. So I've got alpha now, and now I've got beta. So let's just record those. Alpha is 23.4 degrees. Beta is 55.5 degrees. And then it's very easy to find gamma. Okay, so we find gamma, of course, just by doing this. Angle gamma will be 180 degrees minus the sum of the two angles we just found, 23.4 degrees and 55.5 degrees. And then we'll be done with the problem, and then we can check and verify and make sure we got this right. So let's put that in, 180 minus, parentheses, 23.4 degrees plus 55.5. So that's going to work out to be gamma is approximately 101.1 degrees. Okay, so that solves the problem. I'm going to go ahead and go through the checking part of this. So I'm going to go ahead and just put everything in. We found beta to be 55.5 degrees. We found gamma to be 101. So watch how I do this again. I've been doing this over and over again. The repetition's important, that you have the ability to tell you're right. So we're going to do 6.6. I'm going to start with A. It doesn't matter where you start, but you have to divide that by the sine of the angle opposite. Okay, get that answer. Now go to another side like B. 13.7 divided by the sine of its opposite angle. Same thing, approximately. Then to go to C, 16.3 divide by the sine of its opposite angle. And if you get approximately the same thing as we do, then we pretty well know that we've got the right ratios figured out. So that would prove that we've done all of our calculations correctly then. Okay, so I'm going to go ahead and pause this now, give you a few minutes to work on example number 4, and see if you can get the right answer. I believe this is a side angle side case. so let's see how you did here. First, I'm going to start by drawing out a triangle just to kind of help me get everything labeled okay. You can bypass drawing a triangle out, but I recommend it. So I'm going to draw a label. Don't worry about whether it's adjusted to scale or not. I usually just try to get my angles roughly correct. Okay, so we got this. I'm going to label this as my angle gamma, as something I was given as 109.8 degrees. Okay, then I'm going to close the triangle and just kind of arbitrarily label the other things. So let's see, I'm going to call this alpha, and side A opposite that was given as 6.7. That we'll call this beta, and side B was 10.87. So if you look at this, of course, we're given the side angle side case, which tells me that I can use law of cosines. So I'm going to look at this side C, and that's where I'm going to start. Anytime you're given the side angle side case, you want to start with that side opposite the angle that you know. And again, you try to just write this down, the formula down, get it memorized so that you don't have to look it up all the time. So I'm going to say C squared. You always square the side you're trying to find. It's real easy. It's the sum of the squares of the other two sides minus twice the product of the other two sides times the cosine of the angle that's opposite that C, which would be gamma. Now start plugging in. Okay, so A is 6.7. B is 10.87 minus 2 times A, 6.7, times B, 10.87, times the cosine of the angle in between, 109.8. So think of it as sum of squares of other two sides minus twice the product of other two sides times the cosine of the angle in between. It's not that hard to remember, really. All right, now plug it in. Okay, so I'm going to do exactly what I've got on my paper here. So I'm going to do 6.7 squared plus 10.87 squared minus twice the product of the other two sides, 6.7 times 10.87 times the cosine of the angle in between, 109.8, like that. And let's make sure I got that. So I got the sum of the squares of the other two sides minus twice the product, and then the cosine of the angle in between. Now, I think I'm missing my 8.7 maybe. And you need to make sure you have that in there. I always try to double check whether I have stuff on my calculator. All right, so I've got that, and I'm going to record this now as C squared equals 212.5541854. And then I know I'm going to do the square root of both sides. And then I'll go to my calculator to get that approximate answer. So what I do is, since this is stored in the memory key, I just go square root of the answer, round that off to, let's say two decimals, since the B was in 2 decimals. So let's say 14.58 is what C is. Okay, so I've got the first part of the problem done, and I'll go back in my triangle now and label C as 14.58. Okay, now I need to decide which side I want, or which other angle I want. And again, what I want to stress is when you have a side opposite a known angle, then law of sines is going to finish up the next step. So I'm going to pick, I'll just pick beta this time since I know it's side opposite. Or you could do alpha now too if you wanted to, of course. Okay, so let's go ahead and set up our law of sines proportion. We're going to find angle beta. So I'm going to say sine of beta over the length of the opposite side is equal to, now I'm going to go sine of gamma, since I know that angle, and divide by the opposite side. That's going to be a valid law of sines proportion, so we got that set up. Now I'm going to multiply both sides by 10.87, and then I can go to my calculator. So I've got sine of beta is equal to, and I'll go to my calculator and I'll put in 10.87. I recommend you put that before you do the sine. So 109.8 and then divide by 14.58 and get that recorded. So that will be 0.701465978. So now we're going to do the inverse sine since we're trying to find the angle. 701465978. And then I'll go to my calculator again using the answer key. So inverse sine, use answer key. That's going to give approximately 44 let's round this off to one decimal. So we'll say 44.5 degrees for angle beta. Okay, and that leaves us with one more part, which of course is the missing angle. So if you want to find alpha, you now know that we've got this angle is 44.5. So now we just do 180 minus 109.8 degrees minus 44.5 degrees. Get the calculator out, just do that in one step, and then we'll have the problem solved. So 180 minus 109.8 added to 44.5 calculates as 25.7 degrees. Okay, so that should do the problem. Let's do a real quick check-garoo, and let's make sure we got this thing right. So I've got the whole triangle kind of put together here. So now I can go through and check everything. Let's start with side A, 6.7 divided by sine of opposite angle, 25.7, get the answer. Go to side B, 10.87 divided by sine of the opposite angle. Okay, looks like we get about the same thing. Go to side C, 14.58 divided by the sine of its opposite angle, 109.8. And it looks like everything, whoa, I must have obviously put something wrong in there. Let's try that again. 14.58 divided by sine of 109.8. I just totally typed that in wrong. Okay, now if you look at these things, they're all the same. They all turned out to be roughly around 15.5, so that checks and verifies the answer. Okay, so let's see. If we go to the next page, I'm just going to do a couple of applications, and that'll finish this section up. So what I'd like to do with this is solve a couple of problems, a couple of word problems that have to do with law of cosines. Okay, so let's draw a picture on these things as we go. So to begin with this problem, it looks like we have a tower supported by a guy wire again. So I'm just going to draw something, and we're going to call that our tower. And that tower doesn't have to necessarily be at a right angle. That's why I kind of drew it as slanting. But that guy wire is supported by, that would be your wire, and we're going to say that that guy wire has an angle of elevation with the top of 34 degrees like that. Okay, and then that guy wire is 483 feet tall. So that's what I've got so far. Okay, so then it says, with respect to the ground, the distance from the point where the wire is attached to the ground and the tower is 201 feet. Okay, so our job is going to be then to find the height of the tower, which I'm going to use h on that. Now, you do not have to assume this is a right angle. Okay, so since we have a side angle side case, and we want to find the opposite side, then we can use law of cosines. So here's one of the benefits of memorizing law of cosines. So what you do is if you want to find this side in the side angle side case, you just say h is equal to the sum of the squares of the other two sides. I'm going to go ahead and put the units in there, just so you can see how the units come out, minus twice the product of the other two sides, times the cosine of the angle in between. Okay, so I'm going to go ahead and I'm going to work this out, and you're going to end up having square units here. So you have a square foot, that's supposed to be a square, so square foot, and foot times foot is square foot. So the units all work out the way they're supposed to. So let's do this. Let's do 483 squared plus 201 squared minus twice the product of 483 times 201 times the cosine of the angle in between. And then we're going to write that down. It's a pretty big number, so we have 112,719.0907. So it's about 112,000. So I'm going to take the square root of both sides. And then that's going to leave me with what h is equal to approximately. So I just go second square root. Use the answer key for the memory, and that's going to give a height of about 335.7 feet. So that solves that problem. And that's all you have to do on that problem is just find the height of the tower. So it didn't matter whether it was a right angle or not. We had enough information to figure that out. And in fact, we had enough information even if we wanted to figure out that angle. And it may or may not be at a right angle. Okay, so the last problem is kind of an interesting problem. This one says two factories blow their whistles at exactly the same time. If a man hears the two blasts 5.1 seconds and 3 seconds after they are blown, the angle between his lines of sight to the two factories is 41.6. We want to find out how far apart the factories are, and you're given the thing that you need is what the speed of sound is. So what I'm going to do is I'm going to have you just, let's do a little diagram. Let's say that this is factory 1, and over here somewhere is factory 2. Okay, the man is, maybe he's over here somewhere, so here's the man. And what's going on this is the whistles are blowing, and of course when sound emanates, it actually goes kind of circular, kind of goes with waves that are kind of pushing out in all directions. All right, and a couple of things they say on this is they say one of these things, like the whistle from this factory, takes 5.1 seconds to hit the man, and then this factory, since it's a little closer, takes 3.6 seconds. Then it says the angle between his line of sight is 41.6. I didn't draw this to scale, obviously, but it doesn't matter. And then ultimately what we're going to do is we're going to find how far apart the factories are. So we're going to call this distance here distance D, like that. Now, what you have to do on this is you got to use this piece of information to find the sides of the triangle. So one thing that you know, if we wanted to find this distance from this factory to the man, we know that distance equals rate times time. So we could take the rate, which is the speed of sound, which is 344 meters per second, and multiply that by 5.1 seconds. Of course, notice the seconds cancel out, so we'd have a distance in meters. So I just do this on the calculator. I just do 344, the speed of sound, times 5.1, and that gives that this distance here is going to be 1,754.4 meters. Okay, so we have that, and then we're going to do the same thing to find this distance. So we're going to do distance equals rate times time again. This time the rate again is 344 meters per second. The time is 3.6 seconds. Seconds cancel out. Take your calculator and just do 344, the speed of sound, times the amount of time it takes to reach the man. That's going to be a distance traveled. The sound traveled 1,238.4 meters. Okay, so now I've got everything I need to do to solve this problem. So what I've been given in my triangle is I've been given a side, an angle, a side. Then I want to find the side opposite, which is a typical law of cosine situation. So what I'm going to say is if I got the side angle side, if I want to find the side opposite, I square that side. Then I say that's equal to the sum of the squares of the other two sides. So I'm going to go ahead and plug that in. So one of my sides is 1754.4 meters. I'm going to add the other one, 1,238.4 meters, square that, minus twice the product of those two sides. And then times the cosine of the angle that's in between, or 41.6 degrees. Okay, so this is what I'm going to do, is I'm going to do this whole thing in one step on my calculator. Then I'd do the square root of that, and then I'd have the distance. So I'll go ahead and crunch that out in one step. So I've got 1754.4 squared plus 1238.4 squared minus twice the product of those two sides, 1754.4 times 1238.4, and then times the cosine of the angle in between, which was given as 41.6. Okay, so I've summed the square, take the sum of the squares of the two sides, minus twice the product of the two sides times the cosine of the angle in between. Now, I got an error. That means I put something wrong. Anytime this happens, go to your go-to thing, and generally it'll tell you what's wrong. It looks like I have a parenthesis that I don't need there. So I'm just going to take that out, and I'll do it again. So I'll get this big number. So that is 13,62148.433. Then I'm going to do the square root of both sides. And then that should give the answer to the problem. And we'll just round that off maybe to the nearest. The problem says round to the nearest meter. So let's do square root. Use the answer key. That gives about 1167. So we'll just say 1167 meters is how far apart those two factories are. Okay, so it's kind of an interesting problem. You can use sound to measure distances. As long as you know that angle, 41.6, then you can measure those distances. Okay, so that will be the end of this section. It's a pretty short section. Law of cosines usually goes very well for students. Try to get your formulas memorized, and that'll allow you to do your work a little faster. All right, hope this